Yo, what is up, guys? Abu Hassam here. In this tutorial, we are going to talk about data types in the Rust programming language. Rust is a statically typed language, so it should know the type of the data that we pass to it. For example, when we define some variables like this, as you can see here, the IDE is now identifying that the type of the variable is I32, which means 32 bits of signed integer. But how Rust knows this type of variable? For example, if I pass here a string, you can see the type is changed now. So how Rust is knowing the type of these variables is because it infers the type from the value that we pass to it. But sometimes it can't infer the value, as we're going to see in a sec. But we can actually change the type of variable using the colon syntax. For example, I can use the F32 type here, so I can change the type of variable by myself and do not use the inferring type of Rust. But sometimes Rust cannot infer the type of variable. Uh, if you remember from the guessing game, we have some section that we parse the value of input from the user. For example, here, if I use the parse method here, the Rust is unable to infer the type of this variable because internals of this function is ambiguous for the Rust type infer system. And let me print the value here. If I try to run the code, you can, oops, sorry, let me add the placeholder here. If I try to run the code here, you can see it cannot infer the type of the variable, and it's saying that we should explicitly set the type for our variable. And for example, here I can say that is I32, and now we can see the code runs perfectly. So Rust has a perfect inferring type system, but in some situations it cannot infer the type of the variable. So we should, in some places, we should set the type of variable ourselves. In the Rust, there are two general data types. One is scalar and one is compound. Scalar data types are simple data types, and compound data types are the types that are like a collection or some sort of list or array. We are going to talk about them in a moment. But in the scalar types, let's talk about integers first. In Rust, we have I8. Let me add some values here, and U8, which is the uh, lowest amount of integer. Here, I means signed and U means unsigned. So, for example, here we can place -2, and here we should place 2, which is not signed. And let me add another name here, and here we can pass both variables like this. And if you see here, both variables are now printed. But if I try to add a sign for the unsigned variable, you can see here we cannot run this project, and we got an error here that we cannot use an array operator for the unsigned variable. So this is perfect. The Rust compiler do not allow us to use the unary operator for an unsigned variable, which prevent us from having errors later in our program. So there's more of these variables. We have some other type of variables here. For example, we have I16 and U16. So what is the difference between these two is in the amount of memory that these variables are using. How we can find the range that these values are using is using a simple formula. For example, in the I8 variable type, we can find the range using this formula. If uh, we use minus 2, minus 2 in the power of n minus 1, we have the minimum range. For example, if I using the I8, we should replace the n with 8, which means 2 in the power of 7. 8 minus 1 means 7. So this equals to minus 128. So the minimum range is this number, 128. And for the maximum range, we can use this formula, which is 2 in the power of n minus 1, 8 here, and it equals to, oops, sorry, here we should use parenthesis and minus 1. We had a minus 1 here. So here we have 2 in the power of 7 minus 1, which is 127. So this is the maximum range in the I8 for positive numbers. If I run the project, here you can see, and now this is the maximum range for I8. And now if I try to use a larger number, you can here see what happens. The Rust compiler will inform us that we cannot use the number larger than its range. It's the same for the minimum range, and if I try to run, you can see we can't do that. Okay, so now let me talk about other types of integers. Here we have I32 and U32, and I64 and U64, and I128 and U28. So this is the maximum range of the numbers in Rust, which is 128 bits, and this is huge. You can calculate that. And one last thing is the size data type, which is I size and U size. Uh, this size is depending on the architecture of your system. For example, in most systems, we are using the 64-bit architecture. So this would refer to this I64. For 32-bit system, this will refer to I32, and so on for the U size. So all options that we have in integer variables are these, and we can use this type of variables. For example, here you can see, I think I can have a really long number here, and if I use this to print by 4 and fill up this, oops, sorry, let me take this back, and here we need to change the name here. And again, if I run, you can see really long numbers can be fit into the U128. So this is for integer numbers, and we can represent our numbers in multiple ways. Let me show you a little bit of that. For example, here we can use I32 and U32. We can represent our numbers in decimal, for example, 1000. We can represent our numbers in the hex format. For example, we can use the FF, but we should place the 0 and an X here, so the Rust compiler knows that we are passing a hex number. And we can use octal numbers. We should place an O here and a number lower than 8. So this is octal number in the 8th base, and we can use binary notations. For example, use the 0b, and only we can use 1 and 0 here. So if I use 2, you can see it cannot use that number for the binary notation. And there is a special case only for U8 variables that we can use the byte notation. Like this, we can add a B, and here we can use the character that we want here, and the byte of this character would be placed in the variable. We can see here we have 65. If I change it to B, we get 66. So these are integer notations in the Rust. We can use separators to clear numbers. For example, here I can place underscore here. The number is the same number, but for clarity, I can add some underscores here, so I can read them better in this way, and the result is the same. So let me show you X here. You can see the result is the same. So these are the ways we can view numbers in the Rust. In addition to these numbers, we also have the floating point numbers. For example, here I can use a number here. You can see the type is now changed to F64, and we can change the type ourselves to F32, and you can now see the type is changed, and we can use floating point numbers here to represent our values. And let me show you here. You can see now we can use our floating point numbers. And for numbers, we can have operations which we know as numeric operations. For example, we can add them here. I can use, for example, 5 plus 10, which is very obvious. We can subtract them. For example, here I can minus it from 2.4. We can multiply them. For example, here I can multiply these numbers, and as you can see here, Rust is inferring the type if I do not input the type. For example, if I take out the decimal point here, you can see now the type is changed to I32. So Rust inferring type system can define the type for us. And one thing that's nice here, you can see, for example, if I have a variable, and if I divide two decimal numbers here, for example, these two numbers, the Rust can infer the type, and the value is now some decimal number. But in this case, oops, Let me add a more precise number. Here you can see the result is now have decimal numbers. But if I take out the decimal part, you can see now uh, the result is not a floating point number. So the result is like the input numbers. But I cannot divide a floating point number by a simple integer number. If I run, you can see here we got some errors, and it says that it cannot divide a floating point number with an integer number. So both sides should be matched. And there is also another operation in Rust, which is remainder, and you can use this to find the remainder of a division. For example, remainder of, oops, sorry, here I need to update the print. For example, the remainder of 43 divided by 5 is the 3. This operation is useful when you're doing some math calculations in your applications. So there is another type in Rust which is Boolean, and it only has the true and false values. Uh, so it's basically is a on and off situation. You can set either true or false for it. And here you can see the output, which is false for the y variable. And also you can explicitly define the type, which is obvious here, but you can. And the last scalar type in the Rust is the character type, which you can identify with a single quote. Note that this is a single quote, and this is not a double quotation mark. So these are different, and when you use a single quote, this variable becomes the type of the character, and it's only can have a character. If I add another character, you can here see we got some errors here. So this is only a character, and this character type can have UTF-8 characters, which means it can have a lot of characters in it. For example, I can also put some emojis here. If I take the emoji of the crab of rocks, you can here see it accepts the emoji, and if I run the program, here you can see the emoji. So the character type is not a simple character for English characters, and it can include any UTF-8 characters here. So these are the scalar types of the Rust, but we have some other types that are compound types. The first compound type is the tuple type. You can use the parentheses here to create a tuple file. And if you take a look at here, you can see the Rust compiler is inferring the type of the tuple. And now I cannot print the tuple simply. I should select something else from inside the tuple. If I add the dot and select the 0 from the tuple, it will return back the first number here, which is 2. And if I select the first here, you can see the second option is now selected for us. So using tuples, we can save multiple types of data in a compound type, and using the tuple later. Basically, this is a single variable that can have multiple variables inside it. So we call it a compound type. And we can also set the type for it. For example, here I can use I8 and F32 and I8 again. And here you can see now it's perfectly valid, and it can works for us. And also we can extract the value of tuples in Rust. We can extract them like this. If we define the name of variables in a tuple notation, and then after the equal sign we pass the name of the variable, you can see we can extract variables out of it. Now every element of this tuple is a single variable that we can access here. So you can see now we can access every tuple individually using variable names. And let me add the last one here. You can see all of them are now in the output. And one last compound type is the array type, which is basically a list of some values. But unlike the tuples, the values of array should be the same type, and they can't differ in the data type of the values. So for example, here we can print out the first item of array, and you can see we got 1. And if I change this to a floating point number, here you can see now we got some errors, and we should make other variables floating point, so the Rust compiler will not show an error. And now we can see everything is now work perfectly. And you can set the type of array like here. In If you add a brackets here, you can set the type followed by the numbers, uh, the number of elements in the array, like so, which means an array of 5 F32 values. And there is another notation here. You can omit the declaration of array like so, and here you can place a value like 3 and remove this colon here and replace it with a equal sign. Now what this means is that we want an array with 5 items, and every one of them should be 3. So if I catch the first one, we should get the value of 3. And you can see here we have a 3, and if I get the second one, for example, it should also be 3, and so on. So that's useful when you want to have an array that all the elements are the same. For example, we can have all elements with the value of 0. But what if I pass an invalid index to an array? Uh, for example, if I pass the 4, this is perfectly valid. The last item, which is 0, and I can see here the last item 0. But if I pass the 5 here, uh, things aren't going very well here because the index of 5 is invalid, and our index is from 0 to 4, so index is out of bounds. In this situation, Rust won't allow us to compile our program, which is very good. So this will prevent us from having a lot of issues in the future of our app, because this address is invalid, and if it returns some value and do not show us a compile error, our application would be compiled, and we have some invalid data that we don't want to have. Let me show you a better example in another language. If, for example, we have a project in C language, and we want to do the same with an array here. For example, here you see we have an array of numbers. We have 4 numbers here. We print some hello world in C, and let me add it here, hello world in C. And if we choose the first number, which is 25 here, you can see now we have 25 in our output. and we can use another index here, for example 2, which we will get 75 here, and the last index, which is 3, we got 100. But if we use the index of 4, here you can see we do not get any compiler, and our application is compiled perfectly, and the number of 0 is returned. But you can see here cline is inform us that the index is not valid, and this is some invalid index. If I go further and at the 6, you can see now we have a crazy number here. If I run the program again, you can see the number is now changing. This is because our program is accessing an invalid address of the memory of our system, and this is very serious problems, and it can cause many security issues in the applications. Many applications can get hacked using this flaw in the C language. So in Rust, we cannot use this index boundary situation, and we should exactly pass the correct index to our array to be able to compile our program, which is very good for the future of our application. So that was it for this video. I hope you enjoyed this video. Please consider liking and subscribing to our channel. Thanks for watching. Peace out.